Separation of binary mixtures. Introduction. As we know, separation is the first step during the actual analysis of an organic mixture. It is the most important step in the sense that if separation is complete, the result will not be correct because the impure compound will give tests of different functional groups and its melting point will also be very much different from that of the pure compound obtained from complete separation. Although there are physical as well as chemical methods for separating a solid binary mixture, the latter are always preferred, and thence here only the chemical separation is discussed. During chemical separation, it is always preferred to use cold reagents since the application of heat may lead to hydrolysis. However, before proceeding with the separation of the mixture, it is advised that its solubility in a few common reagents and the presence of some of the important functional groups, like carboxylic acid, phenolic, and carbohydrate, must be tested in the mixture as a whole. The presence of either of these groups in the mixture gives a clue regarding the separation. For example, 1. The presence of an acidic group in the mixture indicates that the mixture can be separated by water and/or sodium bicarbonate solution. 2. The presence of a phenolic group in the mixture indicates that the mixture can be separated by water and/or sodium hydroxide solution. 3. The presence of an amino group in the mixture indicates that the mixture can be separated by hydrochloric acid. 4. The presence of carbohydrates in the mixture indicates that the mixture can be separated by ether. Carbohydrates are insoluble in ether. Separation of binary organic mixtures. The usual systematic scheme for separating a solid binary mixture is discussed below. Separation with water. Separation with sodium bicarbonate. Separation with sodium hydroxide. Separation with hydrochloric acid. Separation with organic solvents. Separation with water. Shake a small amount of the mixture with nearly 5 ml of water and note any change in volume of appearance. Even if no change in the appearance of the sample has been noted, filter off the aqueous solution and evaporate the filtrate on a watch glass kept in the boiling water bath. The appearance of a residue on the watch glass shows that one of the components is water soluble, that is, the mixture may be separated with the help of water. After confirming that the mixture is separable by water, shake a large amount of the mixture with water, filter, and evaporate the filtrate to dryness. Wash the residue having insoluble components with water so as to make it completely free from soluble fractions and dry it between sheets of filter paper. Separation with sodium bicarbonate. Take a small amount, nearly 0.25 gm, of the mixture in a test tube and shake it vigorously with 2 to 3 ml of a saturated sodium bicarbonate solution till the effervescences of carbon dioxide stop. Filter the resulting product and treat the filtrate with concentrated hydrochloric acid or glacial acetic acid when the soluble acid will be precipitated out. Filter off the product and dry the precipitate completely between sheets of filter paper. Wash the alkali insoluble product completely with sodium bicarbonate solution and dry it also on the filter paper. A saturated solution of sodium bicarbonate dissolves the acidic component, viz., carboxylic acid, water-soluble phenols, and picric acid, of the mixture. Thus, the soluble component contains carboxylic acid or a water-soluble phenol or picric acid. Separation with sodium hydroxide. Take a small amount, about 0.25 gm, of the mixture in a test tube and treat it with 2 to 3 ml of 2 normal sodium hydroxide solution. Filter the resulting solution and treat the filtrate with concentrated hydrochloric acid or glacial acetic acid when the soluble compound present in the filtrate will be precipitated out. Filter off the product and dry the precipitate completely between sheets of filter paper. Wash the alkali insoluble product completely with the sodium hydroxide solution and dry it also on the filter paper. Carboxylic acids, phenols, amides, and simple sulfonamides are soluble in a dilute sodium hydroxide solution, while the bases, neutral substances, and organic salts remain insoluble in this reagent. Separation with hydrochloric acid. Take a small amount, 0.25 gm, of the mixture in a test tube and treat it with 2 to 3 ml of 2 normal hydrochloric acid, and cool, if necessary, in ice. Filter the resulting product and treat the filtrate with 10N sodium hydroxide solution. When the amino hydrochloride present in the filtrate will be precipitated out as amine. Filter off the product and dry completely the precipitate between sheets of filter paper. Wash the acid-insoluble fragment completely with acid and dry it also on the filter paper. Dilute hydrochloric acid dissolves organic bases to form soluble hydrochlorides. It is important to note that nathalamines form sparingly soluble hydrochlorides, and similarly, nitronamines also dissolve in the reagent with difficulty. Separation with organic solvents, petroleum ether, solvent ether, alcohol, benzene or chloroform. Treat the mixture consecutively with the above organic solvents and filter the product. Allow the filtrate to stand in the air or evaporate it in a water bath for some time. When the solvent is evaporated and the soluble fragment remains on the watch glass. Wash the organic solvent insoluble portion with the corresponding reagent, allowing the residue to stand in the air when the insoluble portion is dyed. Thank you. Please like and subscribe my channel.